implicit differentiation. So let's get started. The first equation, we have x plus y to the 9th power minus 2x to the 4th plus 5y to the 3rd equals to 7. So let's differentiate both sides with respect to x. So we have d dx, and then inside the square bracket we have the entire left hand side, x plus y to the 9 minus 2x to the 4th plus 5y to the 3rd, and then close square bracket, and then d dx 7. Okay, so for the first piece, we have x plus 9 to the 9th power. When you differentiate, you have to use a chain rule. So for the chain rule, we bring the 9 down, and then x plus y. 9 minus 1 is equals to, let's push this up a little bit so I can save more space. And then 9 minus 1 is equals to 8. So regarding the chain rule, I also need to take the derivative of the inside, right? X plus y. So let's write this down. So this is by chain rule. And then the rest, bring the 4 down. We have ax to the 3rd, and then the 3, bring the 3 down. So we have a 15y squared. Am I missing anything? The answer is yes. You are taking the derivative with respect to x, but this term has a y as an independent variable. So you apply the power rule. That's 5, bring the 3 down. 3 times 5 is equals to 15. 3 minus 1 is equals to 2. So when you do implicit differentiation, just say this to yourself. You treat y as x, take the derivative with respect to the independent variable, which is what we just did. So you treat y as x, apply the power rule, and then you write dy dx. So we are missing a dy dx. And then the right hand side, the derivative of 7 is equals to 0. Very easy. And then the next step is we take care of the chain rule. So we have 9, and then x plus y to the 8, and then the derivative of x is equals to 1. The derivative of y is equals to 1, and you have to write dy dx. So this is just a 1 and then times a dy dx. All right, a 1 times a dy dx, and then we have a minus ax to the 3rd plus 15y squared, and then dy dx, we have everything equals to 0. And then the next step is, so this one we have an 8th power, so we don't want to expand that. So how about this? Let's move the ax to the 3rd to the right hand side, and then this we can do a distribution, right? So we can do a distribution, distribute this to here and there. Okay, so we have 1 times that, so 9, and then x plus y to the 8th, and then that times the dy dx, x plus y to the 8th, and then times dy dx, and then the ax to the 3rd, move that to the other side, and then the 15y squared dy dx stays on the left. So we have a positive ax to the 3rd. And then the next step is we are going to subtract this. So we will be moving this to the other side, and then factor out the dy dx. So we factor out the dy dx, and then inside the square bracket we have 9x plus a, right? X plus 8, no, x plus y, x plus y, don't know why I put an 8 right there, x plus y, so x plus y to the 8th power, and then plus 15y squared, close the square bracket, and then on the other side we have ax to the 3rd minus 9, and then x plus y to the 8th power, and then we divide both sides by the square bracket. So at the end of the day, your final answer is dy dx equals to ax to the 3rd, is it the 3rd or square? Ax to the 3rd. Yep, ax to the 3rd. So right here, we bring the 4 down, ax to the 3rd. So ax to the 3rd minus 9, x plus y, keeps writing ax plus y to the 8th, and then divided by 9, x plus y to the 8th, and then plus 15y squared. Do not simplify, do not get rid of the 9 and then the x plus y to the 8. We have a minus on top, a plus on the bottom. They cannot be just simplified like this. And then we box this as our final answer. All right, the first one is done, and then the second one we have Looks like we have a product rule on the x times y raised to the 3 over 2. Let's do it. So first, we do take the derivative with respect to x on both sides. So this is xy to the 3 over 2. And then this is d dx. And then we have x squared plus 1/2 y squared. All right, so this is going to be a product rule. So this is a product rule. And then we call the product rule that is fg prime plus gf prime. All right, and then when you take the derivative of y, you have to do an implicit. So fg prime, okay, we are going to do that right now. So f, we copy x, and then g prime, so we bring the 3 over 2 down, and then take that minus 1. And then since this is a y, you have to read this to yourself, take the derivative, and then you mark dy dx. Mark it, dy dx. And then gf prime, so g is the y term, and then the derivative of x is equals to 1, so this is done. And then the derivative of x squared is 2x. You don't need dy dx because this is already with respect to x. And then the y, you bring the 2 down, and then this is y to the first. So since this is y, you have to mark a dy dx. So the dy dx stays on the left, everything else goes to the right. So this is on the left, and then this goes to the left. So we have 3 over 2 xy 1/2 dy dx. Oh, by the way, some textbook use dy dx and some textbook just use a y prime. And then minus y dy dx, and then equals to 2x minus y raised to 3 over 2. And then you factor, and then you divide, right? So dy dx, and then that is 3 over 2 xy to the 1/2 minus y. So this is a 1, right? 1/2. And then right hand side, no change, y to the 3 over 2. And then finally, so dy dx, so dy dx, so that is equals to 2x minus y raised to 3 over 2. And then this is 3 over 2 x, the y to the 1/2, you can put that as square root of y minus y. If you don't want to keep a 2 as the denominator over there, you can multiply top and bottom by 2. All right, but I will just keep that. So this is your final answer. All right, that is the end of this problem and the end of this video. If you think my instruction and steps are clear and helpful, give me a like, share the video for me. If you are new to the channel, click the like, click the subscribe. I will see you all in the next one. Signing out.